Good day to everyone. My name's Tim, and I thank you very much for taking the time to attend today. Uh, I wanted to offer, as we sit in our first slide and we get the opportunity to engage with you. Um, Engineers are problem solvers, and problem solvers are constantly searching and changing many features and functions in design. One might say, most often, they're challenging the materials and the parameters that make that. I think today, one of the things that we're going to learn a little bit more about is how Sinterit and the team here is doing their best to rise up and meet some of those challenges. So I'd like to introduce today the co-founder and Chief Business Development Officer of Sinterit, Konrad Growacki, and a moderator who behind the scenes is kind of helping us all stay on target and on time, Tomak Stankiewicz. So I thank them for joining us today, and you'll be hearing from Konrad a little bit as we go on. I have probably two very important things, responsibilities for today, and one of my probably first primary responsibility is to say thank you very much for attending today. We sincerely and truly appreciate the opportunity to speak and share with you, and we welcome your input. So without any further ado, I'm going to kind of move into the sequence of our slides for today. And what I wanted to let you know is that as much as we'd like in the world of technology to make this highly interactive between all of us, we're going to do our best to see if we can communicate with you via chat. And if the opportunity arises, we may even take a moment to put one of you on camera or on microphone to share a little bit with us. So please feel free to join us when that time arises. So our agenda for today's presentation should help everyone gather some base knowledge on polypropylene and how Sinterit helps bring you quality and ease of use expected, right? Our products are designed and tested by engineers for engineers. So at the origin of our design was our first compact solution for SLS, the Lisa printer, quickly adopted by many customers around the world as user-friendly and as an ease of use and user-friendly. The engineers of Sinterit were listening to what customers were asking for and provided them with a complete office lab solution when they introduced the Lisa Pro. Our Lisa Pro solution on the right is a turnkey offer, preparing your model or models for nested prints to the final stage, which offer you a complete part in an environment that's safe and clean for your office. So today's focus will be on the application used for polypropylene. I feel it's important to share Sinterit's philosophy on parameters in their wide variety of material offers. I think what we're going to find is that as we make these advancements and share more with you, you'll only see more and more coming from a company that has been solving the challenges of materials in selective laser sintering for over 4 years. So offering this wide variety of unique material solutions is one primary reason Sinterit is bringing polypropylene to you today. You're going to hear a little bit more about the applications of polypropylene, but there is something I would kind of like to share. Here, when you look at the slide, we're talking about a solution, and what could be better than a storyboard of customer challenges, tested and resolved and shared with us so that we can share them with you. No story in this slide holds more emotional weight than the organ printed in red in the upper left corner. The heart of a young child, so accurate and detailed, allowed the doctor to look for the obstructions of this child and come up with a plan for what the surgery and the operation would be like. My hope from some of the outcomes of today would be that at some point in time, you would be our customers and you would be sharing your stories of challenges that have been solved. So I'd like to take a quick second, timely pause, and ask you, what kind of materials do you use for 3D printing? So I'll pause for, say, 10 seconds here and would welcome your sharing.
Yes, sir.
Great.
Hello, everyone.
I think at this point, it's a perfect time to introduce you, Conrad.
Yes. Hello, everyone. It's really pleasure to speak with you today. So as you can find to get some answers on the upper right corner, and to answer the question, it's interesting to see some different results. Later on, we'd like to, for sure, to talk about the applications and where you feel the fit for, especially polypropylene in your work. But feel free to answer what's exactly it's the most common materials you use for your work. It's interesting for us because we are continuously working on new materials, and we would like to be able to add more value to what you're doing all the time. Yeah, so I see that it's more, I think, because previously we did some launching of this material more than a month ago. We have some more answers from FDM users, I think. It's more on the PLA and ABS fight right now, and PC ABS. So there are, I think, the most common materials used for FDM printers. In the previous one, we had more on PA12 users per se. So maybe without waiting more, thank you very much for answers on that. It's nice to see a different audience. I would like to start talking about what we introduced just slightly more a month ago, but still it's quite fresh, I would say, on the market. It's first polypropylene that it's dedicated for compact SLS. So we really work hard to get such a material to our offer because we believe that it's important. And we believe so is that the polypropylene is one of the most commonly used material in the injection molding world. And you know that it's really important to be able to switch to additive manufacturing, and that's one of the way to have this similar material or same material possible to be used in additive manufacturing. And as a result, we had really big interest from our customers, from you, and that's why we are starting with this material and we are offering that to you. But of course, you can ask why it's used, because I see that's not a lot of you used polypropylene in AM before. And beside that, for injection molding, it's one of the cheapest material to be used. It's also lightweight, and it has really great performance both on the mechanical side, temperature side, on the freezing cold for environment, as well as the chemical and water resistance. So this enables to different applications, and it adds some advantages towards currently used materials in SLS 3D printing. But of course, the important is that, okay, so could they use polypropylene on other systems? Yes, you could potentially use it even in FDM systems, but there are some limitations to that. And I would like to mention that why we do the Sinterit, why we essentially work because it's not just to get the next material in our offer, it's about empowering people and get tools and materials to the people to innovate. And we believe that laser sintering is the way to remove a lot of boundaries that are in additive world, and introducing polypropylene, it's the way to go, to the way to get more innovation happen. That's why we believe in that, and that's why we are working on that. So with our polypropylene, we get really great chemical resistance, air and water tightness, and good elongation and break and weldability. But I would like to go a little bit in detail about that. So from the perspective of the common user of laser sintering, we select usually PA11 or PA12, depending on our application. But then there are some of situations where there are some specific acids, solvents, that you cannot use the polyamide at all. So that's why it's important that you have an option to work with alkaline solutions, even some brine solutions to some specific harsh environment applications. And when we work on harsh environments, when we first thing about that, what we usually use is that we have a lot of pressure systems, either with water or with air. So that material is also great to be used with that. And for example, automotive parts are the thing, but let's move on. And when we talk about the mechanical properties, polypropylene and additive manufacturing is not so, extremely resistant from mechanical properties, but its ratio between its specific strength is quite good, with quite good elongation and break. So it adds some ductility for your application with additional features. So that's, we think it's a great benefit to be used for designing your parts. And the thing, it's important, why I personally think the additive manufacturing could work for broader businesses, is that you can do some mixed production runs with this material, because it really can easily weld together with older polypropylene parts, and it's just regular welding for polypropylene enough for that, sufficient for that. So that enables to tremendously improve the efficiency of working with additive manufacturing. For example, with using some base done with injection molding, and use some just adapters, for example, to modify that for given purpose. So the
Conrad,
mobility goes really well there. Yeah?
Allow me to share my favorite characteristic. It's wearability, durability, and wearability, right?
Yes. So that's one of the that's one of the features I haven't mentioned, but that's the thing on polypropylene, that wearability of this material is really great. And to add to that, we have a lot of different things that we should mention, we could discuss, but that's depend on the application. It's what's really needed. For example, for me, the one thing that's important is recyclability. So this material, the parts from this material could be recycled, of course, depending on your application where you use it. But if your application enables for regular recycling, then this material is suitable also for that. So this really step further on what we have right now in additive manufacturing. But when we have the functions, and then we need to go to real applications, and we divided it, at least for now, for 3 parts. But you know that polypropylene is really heavily used by a lot of industries. So this kind of division is, let's say, hard, but that's I think we should start with, and that's the automotive industry, general plastic production, and university and labs and R&Ds. So with automotive industries, we see that pneumatic systems are quite important, and whole air duct for automotives are the places where the polypropylene is heavily used. So with this material, you can easily prototype even really big parts with our system that enables for fast iteration with the comparable end material that will be used for the final part. The next thing I would like to mention is a cap, but it's not just regular cap. It's the liquid coolant cap that is used with some really unique Mercedes-Benz modified machine cars. And we did this part together with Octoclassic, the company that provides replacement parts that are really hard to reach. So there are situations where you cannot use regular AM technologies to get to the parts that has some real functionality, that heavy duty functionality. So that's why this is an example where that's the only way to go with polypropylene. So that's the cap, I think, and then I will give more to Tim to talk about the caps.
Yeah. We have a great example that we're about to share with you, and so we're going to key up this this quick video. We've got a long-standing customer called Slani, and they're of Barcelona. And what they've done is created this design and tested this design. But notice how they incorporated a living hinge in their example. So congratulations to them for doing an excellent job and sharing that with us. So an interesting short story to share with all of you. Recently, the impeller on my boat motor got worn out and wasn't working anymore, so it wasn't cooling the engine. And I purchased 3 of them, and each one of them came up. It was the wrong size for me to fit on the shaft. Eventually, what we ended up doing was scanning and 3D printing one so that it would work. And I thought, boy, what a great example here that we're offering: pumps, impellers, and when we think of making a physical test or performing a physical test to see the product's functionality, everyone who ever attended engineering school can remember this design study of pressure test of fluid flow in a Venturi. The Venturi design is a perfect example of where the ductile strength and wearability and flexibility of polypropylene, along with the accuracy of printing and selective laser sintering, work out perfect.
Yeah, so I would just add a little bit to that. It's also important that all the different sensors that are quite often used in labs need some proper enclosures. So that's the way when you can make the real pressured system possible with some custom sensors. That's the way to go with labs. Yeah? But that's not all of that. In labs, there's a lot of different work with aggressive chemistry, and it depends on. Sometimes you need some special holders. Sometimes the membrane holders, for example, and also some tooling for working with different things, different chemicals, and in harsh environment. And here is where polypropylene shows up really great comparing to other materials that we use for laser sintering. And why you think to print tweezers with polypropylene is that usually you need to, like, if you have some specific tests, you usually need to source really narrow tweezer that you need for this specific tests. And then you need to order that in hundreds, for example, because there is no other way to get it to your lab. And that's why we see this as an opportunity to leverage that and speed up the tests in the labs, that you can easily adjust tooling for your needs and print as much as you need, nothing more. And to add that, we have a little bit more information about the polypropylene as it's known nitrogen needed for this machine, for this material, and it's compatible with all of our printers, with good tensile strength and good elongation and break. So,
hey, Conrad, I wonder if this would be a good time or an opportunity to do a timely pause and see if we could ask Tomak, would anybody, if Tomak, if you can coordinate this for us, let us know. Does anybody in the audience, would you like to share an application where you see polypropylene as a perfect fit for a market or a solution, a challenge that a customer or a project you have might be solved? So, Connor, let's take a minute and see if Tomak can use his magic wand to find someone who's willing to raise their hand and to participate.
Yeah. Yeah, so I think you just need to write that you would like to want that joined. Then Tomek will give you a way to speak. Okay, I think I see a Patrick that you would like to join us. Yeah. So Tomek, please arrange it how to connect. Yeah. So in the meantime, I think it's important to see that like there's different functionalities that could be used in this material, and I think we also have some question from the audience about the refresh ratio. And yes, this material needs to have a refresh, and it's 50%. We work hard to get the best of that. To get continuous results from this material. Yeah, so let's wait if Patrick can join. If there's anyone more that would like to speak on the video, also you can just type it here. It's so then we can queue up. I think that Patrick has a problem to join. Yeah. So, okay, so maybe we'll just wait a second, and if not, we just can move.
Yeah, we can.
Yeah, we can also have some time after that on the Q&A session that we also are open for you to get involved.
Well, we thank Patrick for at least attempting to raise his hand during this opportunity. Yeah. So,
yes, thank you very much. Yeah, so then let's move forward, and then we can maybe connect back later on. So if any one of you would like to share a little bit on your application side on polypropylene, also you can do that in the chat. Or later on the video on the end of the webinar, we'll try to have some time for people that would like to join. Okay. So let's move that to the thing that we believe it's the really important thing in our system is the powder variety, because we have right now 8 materials in our portfolio with an option to use other materials in that system. So the most commonly used material is our PAL12 smooth, which is really cost-efficient way to get great quality parts with tremendous accuracy and detail. So that's the way to go, and that's the most commonly used material for us. And we are also proud that we have really the lowest refresh ratio at 22% of that.
Conrad, can I ask you a question?
Yes.
Just how important is it to have a refresh ratio like that?
So it's important because the one thing is to lower the cost for printing. So this directly connects between the refresh ratio and the cost per kilo of material is directly connected with the cost of the final part. So the lower it's better. So this is the way as right now it's 22%. And we believe that's the way to go with the further materials. We have also the whole range of rubbers where most of them don't need a refresh at all, or the refresh is at the level of 10%, when usually you don't add any of the powder into this system at all. So we have 4 grades of the rubber. First, the Flexa gray is just for like regular prototyping. FlexaSoft is the softest SLS material, TPU material that you can get for real haptic designs. With the FlexaBright, we get really nice color that could be dyed, as well great mechanical properties. And with TPE, we have potential for water tightness as well as skin touch applications. And then we move to other spectrum on the like more performance material, and here we have PL11 Onyx with the 33% refresh ratio, which gets real great work on ductility and tensile strength, as well as elongation at break. So we are really proud of this material, and that it continuously can work with 33% refresh ratio.
Let me ask you, Conrad. Many people have asked me, why the introduction of nitrogen for a material like PA11?
So to make sure that we have the low refresh ratio and we use the powder efficiently, this is needed for this material, and also to make sure that you have the similar results of the printouts on the top and on the bottom of your job. So that are 2 key things why the nitrogen is needed here, and that's why we believe it's like this gives the opportunity to make great parts with low cost.
Great, thank you.
Yeah, and on this also technical grade, we also have PA11 ESD that's got specialized material, because these enable us to get to an environment that needs the safety from electrostatic discharge. So it's special use material, but it's necessary for tooling in electronics and working, for example, in mining industry. So we believe in to broader innovation, we need to have a broader portfolio to address the needs in other industries. But I think that on the last part we left, I think the most important thing when thinking about Sinterit as a system is the openness that we really believe is the key for innovation. Yeah, so the importance of that is that we have a lot of different settings, parameters exposed to our customers. So essentially, we are exposing what we use for our material testing to the customers. So we are really open because we believe in innovation. I think, Tim, you would like to add some more in that for sure.
Yeah. So, Conrad, the idea of open parameters kind of makes Sinterit unique, wouldn't you agree?
Yes.
And
Yes, because essentially when you buy the Lisa Pro, you have it. You have it already. With the price, we give you open parameters as the standard.
so this setting this standard or setting this bar of having open parameters, it's probably one of the reasons for the adoption rate of research institutions and universities making monthly purchases of our product. And I would imagine they're not doing it because they just want to print our materials. I think that these research institutes are innovating and breaking open new barriers. Wouldn't you assume?
Yes, but they need to have a tool, and a tool that it's really affordable. That's because there are two things. One thing is the openness of the parameters, that it's important. But the second part is the size of the machine itself. If you have too big machine, it's really costly to get even small portion of powder to the machine itself. So the inert gas and as well open parameters and the size, really it's great for that part, for innovation in terms of the materials. But there is other spectrum of that, is that also enables the businesses to innovate on their own, because beside that we also add some guidance. It's of course it's not the full study about how to develop the materials, but we also give you a glimpse what each of parameters do, and then you can try what's the best for you. You can slightly adjust what you would like, and you can try to get better results. For example, lower refresh ratio, better tensile strength. That depends on you can really work on that.
So it sounds to me that the combination of mechanical design, great software, and materials is what's providing us the unique high quality output of products.
Yes, and I think essentially on the openness and software, I think it's like today we should talk about more on the polypropylene itself, but we also plan to give you more data about that pretty soon, just this month. We would like to invite you all for the webinar on open parameters, where we'll get really deeper on how to use it really, because most of you might think it's only for labs and researchers. No, we don't believe it. We just want to give this as a way to work for every business, not just researchers, because we believe there is an innovation. If everyone can use it, then the real innovation can happen.
That's great. That's great.
Yeah.
So I think we're probably at that landmark point to say it's time for questions. And when we do, what we'd also like to do is just ask, if you wouldn't mind via the chat, what materials would you like to work with on a compact SLS system?
Maybe I will describe why we are asking this question. Because really we are working hard on next materials to be added into our portfolio. And if you really would like to have a touch and first contact with the new things we are doing, just right now, really, what's your view? What you are seeking right now beside the polypropylene? So then we can really work on that and contact you later on and continue on that side. Then on the previous one, we have some more on, as Marcus Dancy right now mentioned, the glass and carbon filled materials. That's something that we already see. So if you also have this kind of this kind of needs, also please mention. We would like to then contact you as soon as we'll have something. Maybe I shouldn't smile so much.
Yeah, that's great. It's always good
Yeah.
to set up an example perfectly.
Yes.
And while some of those input questions come in, maybe we should start to just sum up a little bit of what we've seen today. So allow me, Conrad, I'll do the first two key points, and then because we've been doing this as a duet, you can kind of wrap us up a little bit. I think first of all, to summarize today, Sinterit is the first to introduce polypropylene to compact selective laser sintering systems. It's also important for me to say our resellers are prepared to give you sample parts and sample materials so that you can start testing the parameters of the designs and challenges that you have. So feel free, reach out to our channel partners, and we look forward to hearing from you and all that. So Conrad,
Yes.
I think I had two major things I need to introduce today. And first was thanking everybody for coming. And I'm going to allow you to do a wrap up before I move to doing the most important thing I have, which is to make sure that I graciously say thank you.
Yeah, so I think that the most for us to also remember is that the openness gives way more abilities that a lot of people thinks, but this is the innovation we see. It's going on, and as I mentioned before, new materials are coming. So feel free to share what you would like to have, and for sure I will contact you as soon as we'll be on some beta phase with something new. So, so I give you back to Tim because we will have some question. Yeah.
Yes. Hey, at this point in time, we're going to test that whole connectivity to our audience again. But as we get ready to take any of your questions, one of the most important things we can do in our world of interacting with engineering design is to make sure that we say our pleases and our thank yous. And so today, it's important for me to thank you for helping us with your attendance, with your questions, your participation. Most important thing and the most important story we could tell is the success of our existing customers. So I look forward to us having continued success with all of you. So at this point in time, I'm going to see if Tomak can queue up answers for the panel here.
So I think we can go with Q&A. So you can get to the questions and just type in some more questions. But I will start with the first question. So on the I think it's something changed. I need to change the ordering. So about the sandblasting. So essentially, depending on what you are using, like when the sandblasting printed part, you can use accuracy. It depends how you do the sandblasting. So what we are doing, we are providing the dedicated solution for sandblasting, which, if properly used, get the lowest loss of accuracy. So, but essentially what we are providing you is with what we are manually doing with the sandblasting. So essentially, if you do it right, so you don't spend in single place a lot of time, then it's fine. That you shouldn't lose a lot, other than the powder grain and what we provide to you as a result of the accuracy. So I think that's the reuse of the powder, I think, is important. So essentially, you can continuously reuse the polypropylene until you mix it 50% of the fresh and 50% of used powder. So that's why it's important to remember that if you mix it up properly, you can work with that continuously. And this is the same with all of our materials. For some of the materials like polypropylene, you will have some lost powder, let's call it, when you cannot reuse it because it stuck up the used powder. But essentially, unless you refresh, you can work with it.
Hey, Conrad, here's a question.
Yeah.
It's from Daniel. PA12 refresh ratio, 22%. I'm not sure if he's making an because it's the written word. Is it, oh my God, or tell us how you did it?
Yeah, so essentially, this is the refresh ratio that is essentially with our powder and tested, and essentially this is the refresh ratio we are continuously using internally in our facility. So we know that we can continuously have the proper mechanical properties using this refresh ratio. This is in our software already, so you can just work with it right away.
That's great. That's great. I've got another question. This question's from Camille. How easy is it to switch between different materials in the Lisa Pro?
It's a really good question because you might think it's switching the material is hard. And then I will answer you, it depends. But essentially, if you, for example, get a PA12 and a PA11, and you would like to switch between these two, with the Lisa or Lisa Pro, it will take around 20 minutes to do a switch. If you ask our tech guys, they will tell you that they will do it below 10 easily. So it's fairly easy to work with different materials in the machines. When we go to the post-processing, it gets a little bit complicated because for our powder handling station, it's a little bit more tricky to switch the materials. But we also have always the option to have our tools and just a sieve. So in the quite inexpensive way, you can have a good setup to work with really other materials. And with that setup, the cleanup and switch is just a few minutes also. So depending on how often you want to switch the materials, of course, that depends. But within the machine, it's really straightforward. And for post-processing, if you don't have a huge volumes for the other materials, then you can do it also fairly easy.
That's great. That's great. So here's an interesting question. Can polypropylene be used for outdoor applications? And does paint or dye stick to this material?
So as you know, the chemical resistance of the material is this pro and cons of this. Yeah. So there are ways to properly post-process that to get paint stick. You can even use some vapor smoothing for that material. There are companies that you could use as a service to do such thing. Our polypropylene has a carbon in it, but it's not fully UV resistant, I would call it. So you can expect way better than results than regular polypropylene, but to make the good mechanical properties of that, we couldn't use more carbon to get this fully UV safe material. You can contact us directly, Marcus, with just your specific application, and we can define and do some tests for you to find out if that will be proper solution for your application then.
That's great. That's nice to share, because it's good to know that with all the intellectual property that's being consumed by the world's first compact selective laser sinter company, we're more than willing to share when it comes to people's unique and specific applications. So let's take another question here. Does polypropylene need to be refreshed?
Yes, so we already spoke about that, but yes, so it needs to be refreshed 50%, and the importance is that it's fairly easy with our system, because we have all the information ready for you to use in the software, also on the machine, how to refresh, how much of new powder it needs to be added, and all the tooling is added to make it really straightforward for doing that.
That's great. That's great. Hey, I think at this time we've probably taken enough questions. And what's interesting,
I think I would just want to answer the last one, okay?
Sure.
From Danielle, because I think it's also quite nice question to be asked. Where do you manufacture your range of powders? So we are a machine manufacturing company. So we are not a chemical conglomerate to make our own polymers. But also that enables us that we work with every big and every great small chemical companies that make powders available. And we are selecting the best one to be used for you. So sometimes we even do some things in our facility, because some things are better to be controlled by us. But essentially, we source that globally, and we source that from the material itself is dedicated for our machines. So this is how we select this one, and we make sure that it works perfectly in our machines. And that's why right now we have several suppliers, and we are working on new suppliers continuously. So we are open for new partnerships all the time. And that's why I'm asking on what materials you would like to have, because we are not limited in the single polymer chain at all. We have the options to get to our suppliers and get some real specific material for your specific application. So
that's great.
I wish that's enough explanation for that.
Yeah.
And I wish that in some time I could tell more about that, but not today.
Yeah. Hey, I'm gonna wrap up our session. I'm gonna add one comment to go with it. Patrick so kindly sent me a text message and said, Tim, if I had the opportunity, I would have shared that he cannot wait to test polypropylene with the application solution for an orthotic laboratory that prints inserts that go in to help people who have problems with their feet that affect their spine and their legs. And that he's had some successful results with some of our other materials, but thinks that polypropylene is going to be the perfect material for that application for orthotic shoe inserts. So Patrick, thank you very much for sharing that with us. So I think at this point in time, I feel as if we've done a nice job of consuming 50 minutes of your time. And gracious to all of you for sharing and attending. So thank you very much from Sinterit.
Thank you very much.